Okay, so I'm doing the kinetics, concentration, temperature effects. How do concentration and temperature influence the rate of a chemical reaction? Well, I think that the higher the temperature, like the faster the reaction, the rate of the chemical reaction like will occur. Same with concentration, I think. Okay. The reaction to be investigated occurs in the beaker when 4 colorless solutions from 4 graduated cylinders are mixed. Different amounts of the solutions can be added together at different specified temperatures. Radio buttons control these amounts and the temperature. A timer can be used to monitor how long it takes for the chemical reaction to proceed to the same level of completeness as the standard solution contained in a second beaker. Okay, it shows the chemical reaction that takes place. The reaction solutions are colorless. The product, iodine, is colorless. As the reaction proceeds, the intensity of color increases, indicating that the concentration of the products is increasing. The reaction is slow enough so that the time it takes to get predetermined color intensity, and therefore a specific iodine concentration can be conveniently timed. A standardized solution is available so that the colors can be matched. If necessary, use the buttons to adjust the volume of the reactant solution to the amounts shown in the following table. Notice that the volume of water is adjusted so that the sum of all solutions when combined equals 100 milliliters. Make sure that the temperature is set to 25 degrees Celsius. Click on the Start button. When the last solution is added, click to start the timer. Pause the timer when the reaction solution changes to a color that matches the color of the standard solution. Record your data. Okay. So we're gonna do 60 milliliters of water, and then 10 milliliters of that, 20 milliliters of that. That needs to be at 10, 25 degrees Celsius. Start. And then we're gonna start the timer when the last thing is poured in there. Okay. And when it changes colors to match that, then I stop the timer. Oh, it looks like it's changing color already. I can't tell if it's getting darker or whatever to match that. I mean, it's kind of already similar. Oh, I think it's changing. So when it gets bright yellow, I'm gonna stop it. I can't really tell. Okay, I think it's about there. It matches enough. Okay. Design trials to test the effect that changing the concentration of each of the reactants has on the rate of the reaction by varying the amounts of the reactants. Try and minimize the number of trials tried. Record the conditions of each trial in the table above. Remember to adjust the amount of water so each trial has 100 milliliters of solution. Enter the parameters of each trial in the simulation and determine the amount of time it takes for this to reach standard color. Okay, so that was 45 seconds. Okay, so now let's change it up a little bit. I'm gonna keep that. I don't really think I can change any. Oh, I need to reset it. That's why. Stupid. I'm gonna do 40 milliliters of that. And then, actually I'm gonna do 50, so that makes it 60. How do I make that to 100 though? I'm gonna do 40, and then that's 50, and then that's 20, 40, 60, 100. And I'm gonna change the temperature. Do I change the temperature or do I change? I don't think I changed the temperature. Okay, start. The timer has been started. It's already changing pretty fast. Oh wow. Yeah, that's already like almost darker. It is darker. I'm gonna have to redo that. Yeah, that needs to be redone. But the concept is like the same. Yeah, that one ended up turning yellow way quicker than the other first trial, so I'm gonna have to stop. I need to pay more attention to that. Yeah, that's like 12 seconds. Okay, so I need to record that.